take a look at claims about two means, and this is where we're dealing with independence. So yeah, one sample, one population is different than the other sample population. Now, testing hypothesis regarding the difference of two independent means. We have simple random samples from two populations. This would be like maybe you're comparing one town to another town, and you're picking random samples from them and wanting to test a claim, whether the average age of this town is greater than this town. Samples are independent of one another. Each sample size is larger, n is greater than 30, or its population is approximately normal. Now here's the classical approach using the TI-83, TI-84, and we're not going to do that in this video. This is going to focus on the p-value approach. And here's the p-value approach. Step 1, write down a shortened version of the claim. Step 2, come up with a null and alternate hypothesis. H0 always has the equals part on it. Step 3, see if the claim matches H0 or H1. Step 4, find a p-value, and that's using a two-sample t-test. And step 5, if p-value is less than alpha, reject H0. If p-value is greater than alpha, accept H0. And then determine the claim based on step 3. Now I use the word accept here, but this is not the norm in most statistic books. They'll use the term do not reject. I find students click better if I use accept and reject instead of the do not reject. But keep that in mind. You may see that in your book. If it says accept this, then another way to write that is do not reject this. Accept is a pretty strong word, though. And let's come down here, and we're going to test this claim. And we'll come back and do the confidence interval. So we're going to do part A here. Okay. It says test whether mu sub 1 is not equal to mu sub 2 at alpha is equal to 0.05 level of significance for the given sample data. So they're telling us mu sub 1 is not equal to mu sub 2. And they're telling alpha is 0.05. And then they give some information. Okay, so for our first population, and we have our second population, we're going to have n, we're going to have x bar, and we'll have s. And it looks like this is 20, 35, 4.3. And then for our second population, we have 15, 34.2, and 5.1. Okay, it looks like all the information they give us. Now, for this population, let's say this is our first town. We're picking 20 people out of random from that town. We find that their sample, if we're talking about ages, this is pretty generic, but if we're talking about ages, then their average sample mean, sample average, is 35. The sample standard deviation would be 4.3 of those 20 people. Then, out of our second town, we pick 15 people, and their sample mean, sample average, is 34.2, and their sample standard deviation is 5.1. Now, we assume, doesn't say it here, but you can assume for purposes of this test that these are normally distributed. Obviously, these are not large samples. Now, always, whatever you put first here is going to be your first list. Whatever you put second here will be your second list. So that's a convention you can follow. Well, let's go back up to our instructions for the claim. Step 1, write down a shortened version of the claim. Well, we did that. Step 2, write down the null and alternate hypothesis. And the not equal to goes on H1. Remember, the only symbols you can put on H1 are less than, greater than, or not equal to. And if that's not equal to, then this will be equal to. If I can draw my symbols right there. There we go. Okay, step 3. See if your claim matches H0 or H1. Well, this matches H1 because they both have a not equal to on them. Then we're going to find the p-value, and it says use 2-samp t-test. 2-samp t-test. So let's bring that up and see what it's asking for. I'm going to go to Stat, left arrow over to Test. Then we want 2-samp t-test, which is our 4th one. So I'm going to down arrow to it and press enter on it, or you can simply press the 4 to choose it. Now we're got data, or we got stats. Data is when you're given raw data. Stats is when you're given summary statistics. Well, we got summary statistics, so we want stats highlighted. If yours isn't highlighted, put your flashing cursor on stats, so if necessary, right arrow over to it and press enter one time. Now it's asking us for x bar sub 1, sx sub 1, and n sub 1, and that corresponds to our first population. So x bar is 35, s is 4.3, n is 20, and then x bar sub 2, and all that refers to our second population. So we got 34.2, s is 5.1, and n is 15. Now this is a symbol off of H1, and our symbol on H1 was a not equal to. So I'm going to put my flashing cursor on not equal to, use your arrow keys if necessary, and press enter one time. Now down arrow. And pooled we always leave as no. Pooled is based upon the assumption that the variances are exactly equal in both populations, which doesn't occur very often. And if it doesn't occur and you say it's pooled and you choose yes, it's a different formula, then you can get some unpredictable results. So always leave that as no. And then we'll choose calculate. Okay, and our p-value is 0.6276. Kind of a large p-value. Just how the numbers came up, I guess. Anyway, step 5. If p-value is less than alpha, well, alpha is 5%, and p-value is like 62%, 63%. So it's not less than. If p-value is greater than alpha, it says accept H0. So for a conclusion, we'll accept H0, which means we'll reject H1. And since our claim matches H1, whatever we say about H1 is what we say about the claim. So we'll reject our claim. Our claim was that they're not equal to each other. And now that I look at it, they do look like they're really close to each other, especially since they got large standard deviations. So that having a large p-value like that does actually make sense. Okay. Now let's come down here and we'll do another claim, and then I'll go back and do the confidence intervals. Okay, so our second problem here, 2a, says state whether, or test whether mu sub 1 is less than mu sub 2. So mu sub 1 is less than mu sub 2 at alpha is equal to 5%. And they tell us for our first population, our second population, we're going to have n, x bar, and s. And they tell us 30, 20, 5.2, and over here we got 28, 18, and 7. Okay, it looks like all the information. So let's come back up here. Step 1. Write down a shortened version of the claim. Well, we did that. Step 2. Come up with a null and alternate hypothesis. H0 always has equals part on it. So for H1, we're going to put the mu sub 1 is less than mu sub 2 here. Reason why, the only symbols you can go on H1 are less than, greater than, or not equal to. Now the only symbols you can have on H0 are less than or equal to, greater than or equal to, or equal to. Now these are opposites of each other, so if this is less than, this is going to be greater than or equal to. Now a lot of books have adopted the convention of just always putting the equals on here, so keep that in mind. There are still a few books around that like to keep these opposites to each other because I think it clicks better with students that way, but personal preference, I suppose. Step 3. See if your claim matches H0 or H1. Well, here's a less than, here's a less than. So our claim matches H1. It then says we're going to use 2-samp t-test. To find a p-value. Okay, so let's go back to our calculator. And I'll press stat, left arrow over to test, and I'll choose 2-samp t-test, which is our fourth one. We again want stats highlighted since we're given summary statistics. If you're given raw data, you would put your first population slash first sample data in L1 and your second population, second sample in L2. And then you come back here and you wouldn't have very much to enter. But summary statistics, we actually just enter them in. So X bar sub 1 is 20. S is 5.2. N is 30. X bar sub 2 is 18. S is 7. And we got 28 again. Assumption is that these are normally disputed since that's not a large sample size. The symbol on H1 is a less than, so I want to right arrow over to the less than and press enter on it. Then I'll down arrow, pooled is always no, down arrow again, and choose calculate. Again, a very large p-value, 0.8874. Oftentimes you have very large p-values or very small ones when you make up the data. It's more reasonable once you're, if you're doing it in real life. I just made up these numbers. Okay, step 5. If p-value is less than alpha, it's not less than, alpha is 5%. This is 88.7%. If p-value is greater than alpha, which it is, so p-value is greater than alpha, it says we're going to accept H0, which means we're going to reject H1, which means we'll reject our claim, because our claim matches H1. Now let's look at our claim. Claim is that the first population mean is less than the second population mean. But when I look at them, I got 20 and 18, not too far apart, especially considering how large these sample sizes are. So when you get a real large p-value like that, well, it's not surprising. Whether it's extreme values, very large or very small, tells you something really there's strong evidence one way or the other about your claim. Okay. Yeah, let's go do the confidence interval now. I got a little bit of a typo here. This should be lower bound plus upper bound divided by 2 for the point estimate. But we're going to choose stat, test, 2-samp t-int for the confidence interval. Okay, so I'm going to come down here, and we're going to do problem 1 again. And specifically, we're going to do 1b. And it says we want to construct a 95% confidence interval. And what do they give us? N, X bar, and S. And so we got 20, 35, 4.3, 15, 34.2, 5.1. And our instructions say to use 2-samp TIent. The int refers to interval, confidence interval. 2 refers we got 2 populations, 2 samples. Okay, so press stat, go over to tests, 2-samp TIent. I'm going to do an up arrow. I might be able to find it faster. I'm not sure where it's at. There it is, 2-samp TIent. Now we're again given raw data, or summary statistics, so we want stats highlighted. It's already highlighted, so I'll do a down arrow. X bar sub 1 is 35. S1 is 4.3. N1 is 20. X bar sub 2 is 34.2. S2 is 5.1. N2 is 15. C level, they want us to find a 95% confidence interval, so we'll put in 0.95. Pooled is again always no. And then choose calculate. Okay. So our confidence interval would be negative 2.544, comma 4.1443. Now this is not the confidence interval of the average of these. We're talking about the differences between them. So going from this to this to this, you know, what's our differences type of question. And so this, how we interpret this is we're 95% confident that the true value of the differences of the population mean falls in this range. Don't know where, but it's somewhere in here. Now, this problem is pretty generic, but typically when it asks you in a real wordy problem, find 95% confidence interval, the differences between this population and this population. The first one listed is the one you put in your N1, X bar sub 1, S1, or your L1, and your second one is the one you put in N2, X bar sub 2, S2, or your L2. Now let's look at 2B. Okay. This one's a 99% confidence interval. And again, we got our population 1, and we got our population 2. N, X bar, and S. So I got 30, 20, 5.2, 28, 18, and 7. So let's go over to our function again, 2-samp TIent. Okay, so I'm going to press my stat, left arrow over tests, and 2-samp TIent. 2-samp TIent. Press enter on it. We're again given summary statistics. I want stats highlighted. Down arrow, X bar sub 1 is 20. S is 5.2. N is 30. X bar sub 2 will be 18. 7. 28. Thought it asked us for pooled last time. I guess it didn't. 99%, 0.99. Oh, it does ask for pooled. Never mind. Just can't remember the order. And then calculate. And we got negative 2.361, comma, 6.3613. And you can round this to whatever decimal places. And again, what this is referring to is the differences between the two population means. So this is not like averaging the two or anything like that. It's finding the differences between them. Yeah, I believe that was the last, yes it was. And that's it for that lesson.